Hello students. Now this is also one of the important topics for end-sem exams in digital communication system, that is probability of error of the match filter. Now to calculate the probability of error of a match filter, we will start with the first maximum signal to noise ratio expressions of the optimum filter. That means a maximum signal to noise ratio of optimum filter is given as x0 square of t upon sigma bracket square maximum equal to, in frequency domain, that is x0 square of t upon sigma square equal to, in frequency domain, minus n of t into minus infinity to plus infinity x of f bracket square into Sni of f into df. For match filter, power spectral density of an input noise signal, that is Sni of f, is given as Sn n0 by 2. That means this, for match filter, the power spectral density, that is Sni of f, is given as n0 by 2. So therefore the expression becomes x0 square of t upon sigma square equal to minus infinity to plus infinity 2 times x of f bracket square into n0 into d of f. But we have seen that x0 of t equal to x0 1 of t minus x0 2 of t, correct? So therefore the expression, the original expression x0 square of t becomes x0 1 of t minus x0 2 of t divided by sigma bracket square equal to 2 upon n0 minus infinity plus infinity x of f bracket square into df. By using Parseval's theorem, we can find out minus infinity to plus infinity x of f bracket square into df equal to minus infinity to plus infinity x square of t into dt equal to 0 to t, because square of t into dt. The integration will change from minus infinity plus infinity to 0 to t, because the bit having time duration from 0 to t. So the x of t, that means x of t also can be written as x1 of t minus x2 of t, correct? Therefore the minus infinity to plus infinity x of f bracket square into df becomes 0 to capital T x1 of t minus x2 of t bracket square into dt, which becomes as, this is nothing but a minus b bracket square, which will becomes 0 to t x1 of t bracket square plus x2 of t bracket square minus 2 times x1 of t into x2 of t to dt, which will come as 0 to t x1 of t bracket square into dt plus 0 to t x2 of t to bracket t dt square minus 0 to t 2 times x1 of t into x2 of t into dt. Therefore minus infinity to plus infinity x of f bracket square into df becomes E1 energy plus E2 energy minus 2 times E1 E2, because this term is nothing but represent energy is nothing but 2 times E of 1 2. E1 is nothing but energy of signal x1 of t, E2 is nothing but signal having energy x2 of t, and this is nothing but energy due to correlation between x1 of t and x2 of t. If we select x1 of x2 of t equal to minus times x1 of t, then this expression of total energy becomes E1 of t equal to E2 of t equal to minus E1 of 2t. Therefore, substituting this value in this expression, minus infinity plus infinity x of f bracket square into df becomes e plus 2e, which is nothing equal to 4e. So therefore, by putting this all this value in our original expression, that is x0 1 of t minus x0 2 of t divided by sigma bracket square equal to 2 upon n0 multiplied by 4e, which is nothing but 8e upon n0. But the probability of error expression, the probability of error expression for optimum filter is nothing but equal to probability of error equal to half error complement functions of square root of x0 1 of t minus x0 2 of t divided by 2 root 2 into sigma. Now substitute the value of this term, that is x0, this part term, or I can write down substituting value of x0 1 of t minus x0 2 of t divided by sigma bracket square term. To get minimum error probability of a match filter, it becomes probability of error equal to half error complement functions of the square root of 2 root 2 into square root of e upon n0, square root of e upon n0 upon 2 root 2, which is nothing but equal to probability of error equal to half error complement functions of square root of e by n0. This is the required expression of matched filter probability of error. I'll repeat the steps. Probability of error for match filter. For that, we have started with the optimum filter maximum signal to noise ratio. The expression is x0 square of t upon sigma square, but this in the frequency domain can be written as minus infinity plus infinity integrations x of f bracket square of Sn of f df. Sn of f is nothing but equal to n0 by 2. So this, writing down these terms, x0 square of t upon 2 sigma square is equal to minus infinity plus infinity 2 x of f bracket square upon n0 into df, correct? But the x0 of t is nothing but equal to x0 1 of t minus x0 2 of t, correct? But this x of t is nothing but equal to original signals, and x0 1 of t minus x0 2 of t by using optimum match filter, x0 of t minus x0 2 of t upon sigma, that means this expression becomes x0 1 of t minus x0 2 upon sigma bracket square equal to this side 2 times x of f bracket square upon n0. But by using Parseval's energy theorem, this side x of f bracket square can be written as in frequency time domain x square of t, but the integration will change from minus infinity plus infinity to 0 to t, because our signal is exist from time duration 0 to t, signal bit is. Now this x of t is but nothing but equal to x1 of t minus x2 of t. We have just seen x0 of t is equal to x0 1 of t minus x0 2 of t. Similarly, for input side, x of t is equal to x1 of t minus x2 of t. So writing this down, x of f bracket square is nothing but equal to x of t bracket square is nothing but equal to x1 of t minus x2 of t bracket square. This is nothing but equal to a minus b bracket square. So writing this formula, but this represents, if I separate down the integration parts, then this represents energy, and it is the energy due to the correlation between two terms, that nothing but. Now if I write down x2 of t is equal to minus times x1 of t, then this becomes E of t is equal to, that is total energy, that will equal to E1 of E1 equal to E2, or equal to minus times E1 of 1 2. So this becomes minus input plus input becomes E plus 2E equal to 4E. So this x0 1 of t minus x0 2 of t upon sigma bracket square becomes 2 times 2 by n0 into 4 times E, that is equal to 8 E n0. But by square down, by taking square root, this part equal to 2 root 2 square root of E upon n0. that is 2 root 2 square root of E upon N0. Correct? So this optimum filter expression, now putting all these values in optimum filter expression, there is probability of error complete functions x01 of t minus x02 of t upon 2 root 2 sigma, that means, or by putting this term value in this expression, it becomes half error complete function 2 root 2 square root of E upon N0 upon 2 root 2. So the 2 root 2 will get cancelled out. It will become probability of error equal to half error complete functions of square root of E upon N0. This is nothing but a expression of match filter, probability of error. Thank you.